Hi, Mr. Corsi here. This video has the complete detailed solutions to all the questions in the AQA Foundation Level GCSE Mathematics Paper 1 exam from 2024. Now there's a lot of questions, but to find the particular question you might be interested in, you just need to scroll along the timeline below the video. So I hope you find these solutions are useful in your journey towards success in your GCSE exam. Well, here's question 1, and in part A we're asked to work out 280 divided by 7. So we're dividing by 7. Worth remembering that the 7 times table starts off like this. And there's 7 times 2, there's 7 times 3, and there's 7 times 4, which is 28. Now there's lots of ways of setting this out and showing you're working. One of the ways some of you will have been taught is to set it out like this. And we go 7 into 2, no. 7 into 28, yes. It goes 4 times. And then either just put a 0 down, or you go through a process of saying 4 7s are 28. When we subtract that, we get 0, and we bring down this 0, and 7 into 0 goes 0. Either way, your answer there is 40. Another way of setting it out would be that way, and you'd say 7 into 28 is 4, remainder 0, and 7 into this 0 just goes 0 times. Another way of thinking, you might be going 7 times 4 is 28. So how would we get 280? We'd multiply it by 10. So we'd have to multiply this 4 by 10. So we get 7 times 40 being 280. So either this or something like this for your working. And the answer is 40. Let's move on to part B. Here we're asked to work out 1062 and subtract 438. So the usual procedure would be 8 from 2 we can't do, so we go to the tens, take 10 from there, that would leave 5 of them, and then add 10 to this 2, which would give us 12. And then if we take 8 from 12, we'll end up with 4. And now in the tens column we've got 3 from 5 is 2. Now in the hundreds column, 4 from 0 we can't do, so we go to the thousands column and we borrow that, and it'll become 10 lots of 100. So 4 hundreds away from 10 hundreds would be 6 hundreds, and we've nothing left in the thousands columns. So our answer would be 624 for that, and that would be a reasonable working to show. So here we have question 2, and in part A we're asked to complete this statement. 2 meters equals, we have to work out how many centimeters that is. Now the clue is in the word centi, and when you see that, you should be thinking 100. One meter would be equal to 100 centimeters. So 2 meters, that would be double this 100, 200 centimeters. So your answer there is 200. Now let's look at part B. And this asks us to complete the statement 8 kilograms equals so many grams. So again, the clue is in the kilo. And kilo, think 1,000. You see, kilo, you think 1,000. So 1 kilogram would be 1,000 grams. So we're asked to find how many grams there are in 8 kilograms. Well, that's 8 times what we've got here. So 8 lots of 1,000, that's just 8,000. So there's your answer. 8 kilograms is 8,000 grams. Now let's finally move on to part C in this question. It's another conversion. We're asked to convert 24 kilometres into miles, but we're given the fact that 8 kilometres is equal to 5 miles. Now, what do we know about 24 kilometres? Well, it's more than 8. And the 8 times table would take us from 8 to 16. 2 8s are 16. 3 8s are 24. So this is 3 times 8. So if 8 kilometres are 5 miles, 3 times, or 3 lots of 8 kilometres would be 3 lots of 5 miles. Now 3 times 5, 15. So 24 kilometres, 15 miles. And that would be sufficient working. You've shown the thinking behind it, and one of the marks will presumably be for your working out how you explain that. Well, here's question 3. And in part A, we're shown a centimetre grid. And it asks us what percentage of this grid is shaded. Now, looking at this, you can see that the same number of squares is shaded as are not shaded. So we've basically got half of the squares being shaded, half of them not being shaded. So 1/2 is shaded. So that's just from an observation, just looking at it. You can see that half of it's shaded, half of it's not shaded. So the question is, what percentage is shaded? Now, we know a half, halfway between 0 and 1. No percent. The whole thing would be 100%. So exactly half, bang in the middle, 50%. So 50% is shaded. 50% is not shaded, the same number of each. So the answer is 50. Now, some of you might have looked at this and started counting squares. I say 1, 2, 3, 4, 5, 6, 7, 8 shaded squares out of total number of squares 4, 8, 12, 16, 4 lots of 4, 16 altogether. And of course that gives us 1/2. Now, you may be using a formula you've been told to change fractions into percentage, multiply by 100%. But anyway, there is 1/2 times 100, and 1/2 of 100 is 50. So again, 50%. So there's various ways that you can work this out. So there's part A. Let's have a look now at part B. We've got another centimetre grid here, and Kai has shaded 2 small squares, and he wants to shade 3/4 of the grid. So what do we know about 1/4 of the grid? Well, one of these columns would be 1/4, and another 1/4, that would give us 1/2. Another 1/4 would be 3/4, then another 1/4 would give you the whole grid. So let's think about columns. There's other ways of doing it, but let's think about columns. Each column is 1/4. So he's wanting to shade the first 3 columns. That would be 3/4 of the grid. So what we can do is shade in these are the squares that I need to shade in. And once I've shaded all these squares with a dot in it, I'll have shaded 3/4 of the grid. Now, be very careful about what the question's asking you. How many more small squares must be shaded? He's already shaded 2, so let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more. So 2 already shaded, 10 more to shade. Okay, now if you want to check that, if he's got another 10 to shade, he'll then have 12 altogether out of, there's 16 squares in total, and you could divide top and bottom, cancel by 4. 4 3s are 12. 4 4s are 16. And that gives us 3/4, and that's what he was asked to shade. He wants to shade 3/4 of the grid. So 12 squares in total. He's already done 2, and that would leave 10 still to shade. So your answer is 10 more. So here's question 4, and in part A we're given a list of 4 numbers. Here they all are, and we have to use one of these numbers from the list to complete each of these statements. First one, number closest in value to 7. Well, let's look at these numbers and let's get on that they're in the hundreds. We'll forget about the decimal point just now. So on the number line, let's put in 690, 700, 710, 720 and 730. And let's try and put these numbers closest to where they are. 692, remember we're forgetting about the decimal point just now. 692 would be around there. 727, oh, that'd be a way along here. 718, oh, just in there maybe. And 714, well, that'd be about there. Now, let's put in the decimal points, now that we've roughly put them on the number line. So we've got a different number line now showing numbers around about 7. So let's see if this helps us. The number closest in value to 7, well, there's 7. There's 7 there. And 6.92 is certainly the closest to 7. So that would be working. Another way of doing that working would be to say, there's 7. Can we take 6.92 away from that? And yes, we can. So there's 2 from 10 is 8, 9 from 9 is 0, 6 from 6 is 0. So what does that mean? It means it's 0.08 away from 7. And if we took 7 from 7.14 to find the difference between these two, that would give us 0.14. Likewise, to this it would be 0.18, and to this it would be 0.27. And the smallest of these differences is this 0.08, which confirms that it's 6.92 that's closest to 7. And then finally, the number that rounds 7.2 to 1 decimal place, there's 7.2. It's likely that it's 7.18. And let's round that. So the 8 is a bit more than 5, so that 1 rounds up to a 2. So certainly 7.18 does round to 7.2. It's the closest number to 7.2. If we look at 7.14, this 4 is less than a 5, so it would round to 7.1, not 7.2. And this would round to 7.3, it's closest to 7.3. This one would round to 6.9, that's what it's closest to. So the number is 7.18. So there's part A. Let's move on to part B. And we're given a list of numbers. Now they're all between negative 10 and 10, and we're asked to use 2 of these numbers from each list to complete each statement. Now, first of all, we have to find 2 numbers that add up to make negative 1. Again, let's have a look at a number line. And if we're at the number 10 and we want to get to the number negative 1, that's going to be 11 places to the left. We'd have to add negative 11. There is no negative 11. What about 6? To get to negative 1, we'd have to go 7 to the left. So we'd have to add negative 7 to 6 to get negative 1. That's not there. What about 4? There's 4. We'd have to go 5 to the left to get negative 1. So we'd have to add negative 5. There is a negative 5. So 4 and negative 5 add up. If we take 4 and we add negative 5, we're going to get negative 1. Starting at 4, 5 to the left on the number line, we end up at negative 1. 2 numbers that multiply to make 20. Well, what numbers do you know that multiply to make 20? 4 5s. 4 5s are 20. There's 4. And there's a negative 5. However, if we multiply a positive 4 by a negative 5, positive times negative gives us negative. So that's not the one we're after. So what other numbers multiplied together give us 20? Well, 2 times 10. Well, there is only one 2. It's a negative 2. negative 2 times positive 10, we've got the same problem. Negative 2 times positive 10, negative times positive, we'll get negative 20. But there is another one involving 10, it's this negative 10. Negative 2 times negative 10, negative times a negative does give us positive. 2 tens are 20. So yes, there are two numbers that multiply to get 20. Negative 2 and negative 10. Well, here's question 5. And in part A, we're shown a picture of 4 lines on a square grid. And we're asked to name the lines which are parallel to each other. Now, if we look at this diagram, line R is horizontal. None of the other lines are horizontal. And that would leave line P as another odd one out. You notice it goes 1 along, 2 up. Line Q and line S both go 2 along and 1 up, 2 along and 1 up. They're going in the same direction. And that's what parallel means. You're looking for lines that go in the same direction. So Q would be going 2 along and 1 up. Sometimes that's written as 2, 1. And also S goes 2 along and 1 up. So that's the same as that. And that would mean they're in the same direction. So they are parallel. So that would be Q and S. Now let's have a look at part B. And here's another diagram. This time we've got numbers on an x-axis and a y-axis. And we're told that there's 4 points on this grid and that both coordinates are whole numbers. Remember, for points x and y, for instance, if we have our x and our y-axis, the point 2, 1 would be 2 along and 1 up. That's 2 and that's 1. So there's the point 2, 1. So the first number tells you how far along the x-axis to go. The second number, the y-coordinate, tells you how far up parallel to the y-axis to go. So 2, 1 would mean 2 along the x-axis, 1 up the y-axis. So that's your x and y coordinates. And we're told finally they're whole numbers and they both add up. The x-coordinate and the y-coordinate add up to 3. And on the axes, we're allowed the numbers 0, 1, 2 and 3. So how do we work out pairs of numbers that add up to 3? Well, let's look at this. 0 plus 3, that adds up to 3. X being 0, y being 3. What about 1 plus 2? That adds up to 3, and that corresponds to a point 1, 2. Now, if we think about it, swapping the x and the y round makes a difference. This point we plotted here, 2 along, 1 up, is not the same as the point 1 along and 2 up. That's a completely different point. So we could add in a different order. We get the same answer 3, but we get different points. X-coordinate here is 1, x-coordinate here is 2, y-coordinate here is 2, y-coordinate here is 1. But both coordinates add up to 3. And can you see one other one? We can do the same swapping business with the 0 and the 3. And that gives us a total, same total 3, but a completely different point. Now it asks us for 4 points. The coordinates add up to 3. All that remains is just to put them clearly on the diagram. So let's start with 0, 3. 0, 3. 1, 2, we go a long one, up 2. 2, 1, we go a long 2, up 1. 3, 0, go a long 3, and we don't go up parallel to the y-axis. So there's 1, 2, 3, 4 points. This is the point 0, 3. This is the point 1, 2. This is the point 2, 1. And this is the point 3, 0. And you can see that adding these two coordinates every time gives us 3. So there's our answer to 5B. Well, here we have question 6. And in part A, we're asked to write down the value of 3 with a little 2 up there. Now you would read that as 3 to the power 2 or 3 squared. And just like 2 times 3, you can read as 2 lots of 3. It tells you how many 3's to add together. 3 raised to the power of 2, this 2 tells you how many 3's to multiply together. So it tells us that we have to take 2 of the 3's and multiply them together. 2 times 3, you'd take a couple of 3's and add them. 3 squared, you'd take a couple of 3's and multiply them. So the value of 3 squared, or 3 to the power 2, would be 9. 3 3's are 9. Part B, write down the value of, now that sign there means the square root of, and if you like, it's the opposite of what we did up here. We're trying to find this time 2 numbers multiplied together that give us 144. Now, you know the square numbers. We can figure some of these out. 2 squared, 2 2's are 4. 3 squared we worked out there is 9. 4 squared is 16. Now you can see they're getting bigger. 5 squared, 5 5's are 25. 6 squared's are 36. I'm producing what's called the square numbers here. 7 times 7, 49. That's 7 squared. 8 squared, 64. 9 squared is 81. 10 squared, and I've still not reached 144 yet, is 100. 10 tens are 100. Now 11 squared, 121. 12 squared is 144. So it's a square number, it's quite big, it's 12 times 12. So the square root of 144 would be 12, because 12 squared is 144. Now let's move on to the last part of this question. Work out the value of 2 to the power 4. Well, remember what we said up here was that this 2 tells us that there's 2 3's that we have to multiply together. This 4 up here tells us that there's 4 2's that we have to multiply together. So just as 4 times 2, 4 lots of 2 would tell us to add 4 2's together to get our 8. This 4 here tells us to multiply 4 2's together. And what does that give us? Well, let's do it gradually. 2 times 2 would be 4. And we've still got a times 2 and another times 2 to do. Well, 4 times 2, that's 8. And we've still got to multiply by this last 2 8 times 2, 16. So when we multiply 4 2's together, we get 16. We're doubling. 2, 4, 8, 16. So the answer is 16. And the working that you show for this would be something similar to this. Well, here we have question 7. And in part A, we're told a restaurant sells pizzas, and they have 3 different types of toppings. They have sweet corn, they have mushrooms, and they have peppers. And we've to complete the table to list all the possible pairs of toppings. Now they have one possibility. They've taken the sweet corns and they've paired it up with the mushrooms. Now what else could we do? I suppose we could have had the sweet corns paired up with the peppers, and I suppose if we left the sweet corns out altogether, we could have mushrooms paired up with peppers. Now you cannot have 3 toppings, that's not allowed, because it's pairs of toppings. These are pairs of toppings and they're all different. There's 3. We have SM, SP, that's a possibility, and MP. That's the third possibility. So that's part A. Now in part B, they're saying dough balls can be ordered in small portions and large portions at this restaurant. A small portion, you get 6 of them. A large portion, you get 10 of them. And a group of people want to order exactly 44 dough balls. So there's nothing left over. Now, let's look at the 6. Now, your 6 times table, 6 and another 6 is 12. 2 6s are 12, and another 6 would give you 18. Another 6, you'd be up to 24. That's 4 6s. Another 6 gets you up to 30. We might as well keep going because 44 is a bit bigger than this. And then another 6 would be 42. But if you add another 6, you get 48. 6 8s are 48. 6 7s are 42. So that's too big. But you'll notice that we cannot get 44 supplied by just ordering small portions. That's all that you'll get in small portions. 2 of the small portions, 3 of them, 4 of them, and so on. Now, if we try 10, a large portion, 2 large portions would have 20, 3 large portions would have 30, 4 large portions would have 40, and then you're past 44. So again, if it's just large portions, you're not going to get 44. So that's not going to work. Let's have a look at 30. Suppose we had 3 large portions. And what does that leave? Well, to get up to 44, that would leave us with 14. Let's look at the small portions. You still can't make up 14 from small portions. 14 left. That's not going to work. So let's try 2 large portions. Now, how many dough balls would be left to get up to our 44? Well, 20 taken away from 44, that would leave us with 24. So this is 2 large portions. That's 20 dough balls. We've still 24 to get. Let's look along this. Look at this. There's 1 small portion, 2 small portions, 3 small portions, 4 small portions. So there's 24 left. 3 small portions would give us the 24 we need. So what is that telling us? It tells us that if we want 44 dough balls, we'll need 2 large portions. That gives us the 20. And 3 small portions. That gives us the 24. 20 plus 24 is 44. So number of small portions 3. Number of large portions is 2. And if you want to just reinforce this, the 3 small portions would be 24 and 2 large portions would be 20. And there's the check that 24 plus 20 does give us 44. Well, here's question 8. And we've got Salma with her £10 and she's buying apples and oranges. Apples are 25 pence each, oranges are 60 pence each. First of all, we're told she buys 9 apples. Well, let's work out how much she spends on apples. Well, we know each apple costs 25 pence. So if we multiply 25 by 9, we should be able to work out what she's spent. Well, 9 5s are 45, and that's a 4 we need to carry. 9 2s are 18, and that 4 gives us 22. So the 9 apples cost £2.25. That answers in pence there. So another way you can work it out is to say, well, we know a couple of 25s gives us 50, and another couple of 25s gives us another 50, and a couple of 50s would be £1. So she's bought 4 apples for £1. She's still got another £1, and that would involve buying another 4 apples. So there she is with her 8 apples, having spent £2. So she's got 1 apple still to buy. That'll cost her 25p. So all in all, £2.25. So that's another way of doing it. So multiplication, or figure it out that way. So anyway, what's she got left? So our money that's left, you have to take away from £10, £2.25. So if we do a subtraction, 5 from 0 doesn't go, we go all the way along. We'll take that. We'll take one of these. We'll take one of these. So we've got 5 from 10, that's 5. 2 from 9 is 7. 2 from 9 is 7. So the money she's got left, £7.75. Another way you could have thought of it is if she's got £10 and she spends £2, she'd be left with £8. But she doesn't spend £2, she spends another 25 pence. Well, if you spend 25 pence from your £8, you're going to have £7.75 left, because that 25 pence reduces from £8 to £7.75. So either way, there's what she's got left for the oranges. Now, how many oranges can she buy? Well, the oranges cost 60 pence each. She has 775 pennies. Oranges costs 60 pence. So we'd be doing this division. How many 60 pences are there in 775 pence? So 60 into 77 goes once, 1 times the 60, and then we do a subtraction. So that's 7, 6 from 7 is 1, and we bring this 5 down. And 60 into 175, well, a couple of 60s, 2 6s are 12, that would be 120. 3 6s are 18, that would be 180. So it's 2, and we'll double check, 2 lots of 60s, 120. Do your subtraction. 2 from 7 is 5. We've got 55 pence left, not quite enough for a whole orange. So she buys 12 oranges. She's got 55 pence left. Another way you could have done it was to say, well, okay, let's do what we did up here. There's an orange, there's another orange, and so on. We could stop off at 10 oranges, because we know that 10 lots of 60 would be 600. That's £6. What have we got left? Well, another 60 and another 60 would be £101.20, 120 pence, £1.20, that's £7.20, and another 60 would be too much. That would be £1.80 onto this. That would be £7.80. No, we don't have enough. So there's £1.20 from another 2. So that gives us a total of £7.20 she can spend buying 10 plus 2, 12 oranges. So in total, how many oranges does she buy? 12 oranges. And either this long division or something akin to this type of working would be suitable to fill in there, like to gain your 4 marks. You must show working to gain full marks. Well, here's question 9, and we're told that Alina and Sue play netball, and here's a table showing the number of goals that they scored in 8 games each. And we have to complete this table, which shows the range of these data, these numbers, and the median in each case. So let's take the first column. Let's have a look at what we mean by the range. And the range is given in the case of Sue. And you'll notice these are in order. They're increasing in size, these numbers, and they go from 13 up to 31. And let's look at the gap between 13 and 31, the difference between these two numbers. So 3 from 11 is 8, 1 from 2 is 1. There's Sue's range. There's a gap of 18, or a difference of 18, between the smallest and the largest of the number of goals that she scored. That's why they've got a range of 18. Let's do the same for Alina. Now let's look at her smallest number of goals. It's 12, and our greatest number of goals is 26. So we have 26, and the difference between 12 and 26, 2 from 6 is 4, 1 from 2 is 1, that's 14. So the range for Alina's goals in these 8 games is 14. That's the gap between her smallest number of goals and our greatest number of goals. Now let's have a look at the median and what that means. Now we are given the median for Alina, so let's look at the goals that Alina scored, and that will help us to understand what we mean by the median. So there's 8 numbers in total, 8 numbers. And if we look for the middle number, it's not there. There is no precise middle number. There's 4 to the left of this dotted line and 4 to the right of this dotted line. And if we look at 17 and 21, there's a gap of 4 between these two numbers. So halfway between 17 and 21 would be 19. That's halfway between 17 and 21. Another way of getting that number would be adding the 17 to the 21 and halving your result. Add 17 and 21, you'll find you get 38. And a half of 38 is 19. So that's the number halfway between 17 and 21. And that is the median. So let's recap. If you have a list of numbers and they're in increasing order, that's vital. They have to be in increasing order, and you look for the middle one would be the median. If there is no middle one, then we take the average of the middle 2, the number halfway between the middle 2, that's the median. So let's have a look at Sue's numbers. She scored in the 8 games 13, 13, 17, 20, 22, 23, 24 and 31. So again, there is no middle number, so we'd be looking for a number halfway between 20 and 22. Well, that's 21. So in her case, her median is 21. So moving on to part B, we're asked which player scored the more consistent number of goals. Now that's to do with the range of goals. I mean, if they were totally consistent, for instance, suppose Alina had scored 17 goals in every single match, you would say, wow, that's extremely consistent. And then if Sue, for instance, had scored 1, 10, 150, inconsistent. They're just all over the shop. Now, how we measure consistency is by the range that we found in part A. If we look at Alina, her range is 14. From her smallest to her largest, there's only a gap of 14. That's more consistent than Sue. Sue's got a range of 18. That means between her least and her greatest score, there's more of a gap. They're more spread out. They're more inconsistent. The variation around about the median, if you like, the middle value, is a lot more for Sue than it is for Alina. So we'd say that Alina is the most consistent, and we'll give a reason for this answer. Alina's range, which is 14, is less than Sue's range of 18. And that's sufficient reason. If the range is less, it's more consistent. Well, here's question 10. We're asked to work out 35% of 1,200. Now, there's various ways of doing this. We could go ahead and say, well, we know that 35% is 35 hundredths. So it's that fraction of 1,200. And we can use our normal fraction calculation to do this. We'd say, okay, we can divide by 100, top and bottom. 100 into 100 goes once. 100 into 1200 goes 12 times. So on the top we're left with 35 times 12, and we've just got a 1 in the bottom of this fraction. So what is 35 times 12? Now you can either do long multiplication, 2 5's 10, 2 3's are 6 plus that 1's 7, 1 times 35, and add. And we get 420. So that's our answer, 420. I mean, instead of this long multiplication, we could say, well, if we're dealing with 35, we know that 10 lots of 35 is 350, and we have to add another 2 lots of 35. 2 lots of 35 is 70. So we can add up, there's 12, and we get exactly the same. But there's various ways of doing that. Now, another way we can possibly do this is to say, well, okay, 10% of 1,200. 10% is 1/10. If we divide 1,200 by 10, we get 120. So we can say that 10% gives us 120. Another 10% would give us another 120. And another 10% would give us another 120. So we're so far have 30%. How do we get the final 5%? Well, that's a half of 10%. So 5% will be a half of 120. That's 60. And we can just add up all these to get our 35%. And then add up all of these. 0, 0, 0, 0, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. And there's our 420 again. Lots of ways of doing it. 420 is our answer. Well, here's question 11. And we've got a window cleaner who uses this formula to calculate the cost when he cleans his customers' windows. We're told that C is the cost that he's going to charge the customer. What he does is in this formula. Now, what does this formula mean? Well, this says 2 times W. W seemingly is the number of windows. So this says double the number of windows. And that's not all that the formula does, because there's a second part to it. It says add 5. Well, that's clear enough. There's the process that we go through. We double the number of windows and we add 5. That'll produce the cost. So, how much does it cost for 6 windows to be cleaned? So we double the number of windows and then add 5. So the cost will be 12, 2 6's are 12, plus 5. And if we add 5 to 12, we get 17. And that's measured in pounds. So it's 17 pounds that is charged. Let's move on to part B. The cost for another customer was £24, but the customer thinks this must be incorrect. We've to give a reason why that must be true. Well, it's worth looking at the various totals that the cleaner charges. So if you like, we're going to make up a table showing the costs and the number of windows. So for instance, a house with one window, a dark house, you double the number of windows, that's 2, and add 5. That'll give us 7. Cost of 7. House with 2 windows, doubling 2 gives us 4. Add 5 and you get 9. House with 3 windows, double 3 you get 6. 6 plus 5, 11. Now you'll notice there's a pattern emerging. We add 2 every time. Let's just do one more before we use that pattern, just to double check. We double the 4, we get 8. 8 plus 5 does give us 13. So the pattern is add 2 to get the next term. So we add 2 to 13, we'll get up to 15, 17, 19, 21, 23, 25. Now we can stop there. The customer was charged 24. There is no such house. A house with 9 windows would be charged £23, and a house with 10 windows would be charged £25. So there is no house that would be charged £24. So the reason is £24 total does not appear. All the possible totals that can be charged, it's not there. So in your answer to this, you would put something like that as you're working. Now there is another completely different way of doing this. 2W is always going to be an even number. When we double 1 we get 2, 4, 6, 8. They're all even. We could say that 2W is always even. 5 we know is odd. And when you add an even and an odd number together, you're always going to get an odd answer. So 2W plus 5 is odd. All the totals will be odd. £24 that was charged to this customer is even, so not possible. So there's another entirely different way of doing it. And you'll notice in this table you can see all these totals, they're all odd numbers. So double W, even. 5 odd, even plus odd is odd. 2W plus 5 therefore is odd. £24 totals even. All the totals are odd, so it's not possible. So here's question 12, and we've got a couple of bags of discs. Bag X and inside another bag, we'll call this bag Y, and we're told that 7/20ths in this one are red and 2/5 in this one are red. Now, we have no idea how many discs are in there, but we can speculate. We could say, suppose there's 20 discs in this bag, how many would be red? Well, just 7. Otherwise, we wouldn't get 7 out of 20 discs being red. And what about this bag? Well, if there were 5 discs in this bag, we know that 2 of them would be red. Otherwise, we wouldn't get 2 out of 5 discs being red. Now, we can see, to compare, we would need to add more discs to this bag so that we ended up with 20 in here. So we could add another 5 discs. That would give us 10. That means we're adding another 2 red ones. Another 5 discs. That takes us up to 15. That adds another 2 reds. And finally, if we add our last 5 discs in, we'll have 20 discs. That adds another 2 red discs. So, what have we got? 2, 4, 6, 8. We've got 8 red discs when we have 20 discs in the second bag. So, what's the greater proportion? Well, in the red bag, we've got the same number of discs in each now, but we have 8 red ones compared to 7 red ones. So 8/20ths compared to 7/20ths. And 7/20ths is less than 8/20ths. So this is the greater proportion. So we can say that Y has the greater proportion of red discs than X. And we still don't know how many discs are in these bags. Well, here's question 13. And in part A, we're told that 2 friends share £240 between them in the ratio 1:3. And we have to work out the larger share. So the 2 friends, here's the £240. And the first person says, right, I'm going to get 1 lot. The other person says, well, I'm going to get 3 lots. And each of these lots is the same. So we have 4 lots, all the same. So we have to divide 240 by 4. So 4 6s are 24. And 4 into this goes 0. So it looks like we've got 60 for each of these. And we can double check that. 3 lots of 60. 3 6s are 18. That would be £180. Compared to £60. And just check, the bigger share is 180, the smaller share is 60. Let's add them. 0, 6 plus 8, that's 14. 1 and 1 is 2. That gives us our £240. So the larger share is £180. Let's move on to part B. And in this part, we're told that a tennis player wins or loses matches in the ratio 5 wins to 9 losses. And what fraction of the matches do they win? Well, here's 5 winning matches, and here's 9 losing matches. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many matches altogether? Well, we've got 9, 10, 11, 12, 13, 14 altogether. So 14 matches. What fraction of the matches do they win? Well, how many wins do we have? 1, 2, 3, 4, 5. We've got 5 wins out of 14 matches. 5 out of 14. So the fraction of matches that they win is 5/14. Well, here's question 14. And in part A, we've asked to use this multiplication table to work out the answer to this question. Now, if we look at a simple multiplication, for instance, one as simple as this, where we can say 3 times 2 is 6. Or another way of saying that is 6 divided by 2 would give us 3. Or 6 divided by 3 would give us 2. So the part of the table that we're interested in here is 3, 8, 4, 3. Now, can we find that in the table? Well, there it is. And we've got a 63 times a 61. 63 times a 61. So we know from that table that 63 times 61 is equal to 3,843. But there are other ways of writing that. You see, here we said 6 divided by 2 gives us 3. Here we could say 3,843 divided by 61 gives me 63. Or, in this case, we said 6 divided by 3 gives us 2. 3,843 divided by 63 will give us 61. So there's another 2 ways of writing the fact that 63 times 61 is 3,843. Now, when asked to do the divide by 63, the answer will be 61, as you can see from all this working. So next, part B. And in this part, we're asked to work out 6.1 times 6.7. Now, how is it connected to this table? We have a 61, we have a 67, but we don't have a 6.1 or a 6.7, but that must be the part of the table that we're going to use. 61 times 67, and from the table we know that equals 4,087. And how can we now use that to work out 6.1 times 6.7? In other words, where does the decimal point go in this? Now, there's several ways of doing that. We can think this is roughly 6, this is roughly 7, and we know 6 times 7 is 42. So where would the decimal point be for this to be roughly 42? Well, it would have to go between the 0 and the 8. If it went between the 4 and the 0, we'd get a number 4 and a bit. If it went in there between 8 and the 7, it would be away up in the hundreds. So the closest to 6 times 7, 42, is this. Another way of doing this is just to count the number of figures to the right of a decimal point. There's 1 there, there's another 1 there, so in the answer there's going to be 2. We just add up the number of figures to the right of the decimal point. So either way, the answer is 40.87. So finally, let's move on to part C. And in this case, we're asked to work out 63 times 66. Now, unfortunately, the table doesn't have a 66. It's got a 65, and we know the answer to 63 times 65 is 4095. Doesn't have a 66, but it does have a 67. And we know the answer to 63 times 67 is 4221. So the question is, what on earth is that missing number? Well, again, there's several ways of doing that. One of the ways could be to say, well, look, this tells us this 4095 is 65 lots of 63. This one tells us 67 lots of 63. In between 66 lots of 63, that would be one more 63 than 65 lots of 63. So we could take the 4095 and add 63 to it. 65 lots of 63 is this. So adding another lot of 63, that will give us 66 lots of 63, will give us, well, that's 8, 9 plus 6 is 15, 1 and 0 is 1, 4. And there we go, 4, 1, 5, 8. Or you could work from 67 lots of 63, which is 4221, and take one lot of 63 away. You start with 67 lots of 63. To get 66 lots of 63, we'd take a 63 away from that total. So we could take 3 from 1. That's really 3 from 11. 6 from 1. Well, there's 6 from 11. Nothing from 1, and there's a 4. And that gives us exactly the same answer. So our answer is 4158. Now there's yet another method of doing it. We could say that this number that's missing would be halfway between 4095 and 4221. We could add up the two of them and divide by 2. Let's see if that works. So adding up 6, that's 11, 2 and 1 is 3, 4 and 4 is 8. And then to find halfway between them, we would divide by 2. So we've got 2 into 8, 3, 1, 6. So 2 into 8 goes 4. 2 into 3 goes 1 with 1 over. 2 into 11 goes 5 with 1 over. 2 into 16 goes 8. And again, we've got exactly the same answer. So I think there's 3 methods that we've got the same answer from. So here's question 15. And we're given a couple of triangles, and we're told that they're congruent. Here they are. Now, what does congruent mean when we're talking about two triangles? Well, let's take this triangle on the right. If it's congruent to this triangle on the left, we would be able to cut this out, this shape, cut it out, lift it up, maybe turn it round, turn it over, but it would fit on top of this triangle exactly. So let's think about that. Let's look first of all at this big long 8 centimetre side. And I'm going to call it the red side. Now if I pick up this triangle, maybe turn it over or whatever, and it fits exactly on top of this triangle, the 8 centimetre side would have to fit exactly along this 8 centimetre side. So that 8 centimetres fits along this 8 centimetre. Let's now look at the 5 centimetre side. This 5 centimetre side, and let's call it the green side. When that triangle's picked up, that 5 centimetre side would have to fit exactly on this other 5 centimetre side. So what does that leave us? Well, it leaves us this side with an X on it, and let's call that the blue side. And it's going to fit, well, there's only one side left. It would have to fit on top of that side there. So we pick up the triangle on the right. It would actually have to be turned over and then place it, turn it round a bit, and it would fit exactly on top of this triangle. So the side that we're trying to find the length of would fit exactly along that 6 centimetre side. So X equals 6 centimetres. Well, here's question 16. And we're told that C and D are positive numbers, with C being even and D being odd. So C could be numbers like 2 and 4 and 6 and 8 and so on, whereas D could be numbers like 1 and 3 and 5 and 7 and so on. So there's examples of even numbers and odd numbers. Now we're asked to tick a box for each expression, so let's have a look at C plus D. Well, we could try some of these. Suppose we take an even number, 4 for instance, and add an odd number, 3 for instance, and look, we get an odd answer. We'll try another one, 2 for an even number, 1 for an odd number. Even plus odd will always give us odd. Let's write that down. C plus D will give us an odd answer. Now let's look at 4C. 4 times C. Now that's like 4 times 2, 4 times 4, 4 times 6, and so on. These are all even numbers. Now this last one, C divided by 2, to take an even number and divide it by 2. So we take 2 and divide it by 2. We get 1. So does that mean they're all going to be odd? Well, let's try the next even number. Oh, that one's 2. And the next one, that's odd. I bet the next one's even. There it is, it's even. It goes odd, even, odd, even. So if you take an even number and divide it by 2, you're not going to be able to tell whether the answer is even or odd until you know what the number C is. So you really cannot tell until someone tells you what number you're dividing by 2. Well, here we have question 17, and we're told that there's a linear sequence that has a first term, 10, and when you add the first two terms, you get 39. We're asked to work out the fifth term. So there's a first term, a second term, there's a third term. Now it's a linear sequence. So what that means is that there's a rule that you add the same number to one term to get the next. Add the same number, add the same number. So let's just remember that as we're looking at this. Now what do we know? The first term is 10. And that if you add the first term and the second term, you get 39. So this number plus this number gives us 39. Well, if you take 10 away from 39, you'll get 29. 10 plus 29 gives us 39. So there's the first two terms. Now, as I said, a linear sequence means you add the same number all the way along the sequence of numbers. So from one term to the next, you add the same number. You add the same number. You add the same number. So that's how we're going to get to the fifth term. So what do we add to the first term to get the second term? Well, we take 10 from 29, we'll get 19. So the rule for building up this linear sequence would be add 19 to each term to get the next term. So 29 plus 19. Now there is a quick way of adding 19. Suppose you added 20, then you'd have to take one away. So if I add 20 to 29, I get 49, and take one away, 48. Now if you're not happy with that, you just do your little addition every time. 9 and 9 is 18. 1 and 1 and 2 is 4. So you get your 48. Add another 19. Let's add 20. That's 48 plus 20, 68. And take one away, 67. Let's add 20 and take one away. 67 plus 20, 87. Take one away, 86. So our answer is 86. Now there is another way of doing it where you start out with 10 to get the second term, add 119. Third term, add 2 19s. The fourth term, you'd be adding 3 19s. The fifth term, adding 4 19s. So if you work out what 4 19s are, 4 9s are 36, 3 to carry, 4 1s are 4, plus the 3 is 7. So you would be adding 76 onto the 10, and that certainly gives you 86. Well, here we have question 18, and we're shown a triangle, and we're asked to work out the area of that triangle. So let's think about this. One of the ways we can do this is by using the triangle area formula, and that's a half of this base 20 times this height of 6.3. Half base times height. And why that works, you can imagine a rectangle surrounding this triangle. You know the area of a rectangle is the length times the breadth. That breadth is the same as this height, 6.3. So to work out the area of the whole rectangle, you'd do 20 times 6.3. And then the triangle is a half of that area. You see this bit here? Same as this bit. This bit here? Same as this bit. So the area of that triangle is 1/2 the area of the big rectangle. So a half base times height is the formula that you use. Now the base is 20, the height is 6.3. So a half of 20 is 10. And you know how to multiply something like 6.3 by 10. The units become tens and the tenths become units. So it's 63 point. If you like, the point moves 1 to the right. So 63, and it's an area, that would be square centimetres. So the answer, 63 square centimetre. Well, here's question 19. And we're told that this vector translates A to B. We're asked to find the vector that translates B back to A. Well, let's have a wee look at a grid. Now, a vector like this that has the numbers -3 and 7, the components as they're called. The first number is a left and right number. Left or right, we should say. And the bottom number is an up or down number. Now, just as your axes, that would be negative and that would be positive if we're going left and right. So if we're looking at the first number being negative, then we would go 3 to the left. The second one being positive, well, that's an up direction. Up, down being negative. So we start off with the point A, we go 3 to the left, then 7 up. So suppose we start here. 1, 2, 3 to the left, 1, 2, 3, 4, 5, 6, 7 up. And that gets us to the point B. So let's join that up with a straight line. There we go. Now, if we're looking for the vector that translates B or moves B back to A in that direction, well, what must we do? We go 3 to the right and 7 down. Now 3 to the right would be positive 3 and 7 down would be negative 7. So we've changed the sign of each of these components. If you like, we've got the negative of that original vector, and that's positive 3, negative 7. So let's put these components in. The x component's 3 and the y component is negative 7. Well, here we have question 20, and we're told that a rugby match had an audience of 8,400. It's the number of people that attended the rugby match. And we have to write down the minimum possible attendance if that was a figure that was rounded to the nearest 100. So let's think about a number line. And we have 8,400. Since we're talking about to the nearest 100, going up 100 would get us to 8,500. And going down 100 would take us to 8,300. Now the answer we get when we round it to the nearest 100 is 8,400. So the borderline between each of these hundreds is 8,350 and 8,450. So is the minimum possible attendance 8,350? Well, if you look at this and you're asked to round it to the nearest 100, you look at the end and you say, well, this is exactly a 5. I've been taught to round that 3 up to a 4. That's my rule. So 8,350 to the nearest 100, chop off this 50 at the end, and that 3 would go up to a 4. So you would get 8,400. If you went one less than 8,350 and you were looking at 8,349, if you were rounding that to the nearest 100, you'd say, oh, 49 chopped off, that 3 would stay, would be going to 8,300. It's nearer to 8,300 to 8,400. Now, interestingly, 8,350 is precisely halfway between these two, so we do need a rule. And the rule says move it up. So 8,350 would round up to 8,400. Let's have a look at part B. It says write down the maximum possible attendance. Well, let's move on to the 8,450. And from what we've just said, if you're chopping that 50 off, you would round it up. And this figure, 8,450, would go up to 8,500. So this can't be the maximum possible attendance. What about one less? What about 8,449? Well, if you round that to the nearest 100, it is nearer to 8,400 than it is to 8,500. There's no doubt it's less than halfway. So that would get rounded to 8,400. That must be the maximum attendance. Since 8,450 is halfway between these two numbers, you must round it up. So 8,449 is the answer. Well, here we have question 21. In this question we're shown a table. This table is telling us the number of workers at a company starting in the year 2015 and working all our way through up to the year 2022. You can see the number of workers is increasing as time goes on. And a time series graph is drawn to represent this data. Well, let's have a look at that graph. There it is. There's the years along the bottom axis, and the number of workers is shown up this vertical axis. Now, you should be very careful about what each little square represents. And you'll notice there's 5 squares between 20 and 30, 5 squares between 0 and 10. Each square must represent 2. We get 2, 4, 6, 8, 10. So that's worth remembering. So the first 4 points have been plotted. Let's just check that. There's 10, 20. We're just half a square short of 30. That's 29. Half a square would represent 1. 34, that's 30 2 squares above it, because each square represents 2. So there's 34. 42 is the next one. That's 1 square above the 40 line. And 52, 1 square above the 50 line. Now, in part A, we're asked to complete the graph. So we've reached 52. We're moving on to 2019 with 62. So we go up this heavy line here to 60, 1 square above that. That's where our cross would go. And then, of course, we must join these 2 points up. So get your ruler going and join them up. So the next year, 2020, and that's 70. Again, let's get the ruler onto that. (2021) 76. 72, 4, 6. That would be 3 squares above the 70 line. And finally, 2022, that's 80. 2022, 80. Now you notice that's less of an increase. So that's the completed graph. Let's have a look at part B. It says estimate the number of workers at the company in 2023. So there's 2023. That's up this line. So you'll notice that it was a lot steeper here. It's getting less steep, so the increase is less than it was. Let's just assume that it was the same as that previous one between 2021 and 2022. Let's see where that line takes us. That looks like 2, 4 and half a square. It looks like 85. So 85 would be a good estimate for that. And let's just draw that in. I'm putting it in a different colour to show that that was our estimate. So 85 would be my estimate for that. And what I'm doing is assuming that increase is the same as last year. That's the best I can do. So here's question 22, and we're given a cone. We're told the radius is 5, that this perpendicular height is 12, and this slant height is 13. Now these words that I used are going to be important. This is the slant height. This is the perpendicular height. And of course this is the radius. Now the base of that cone is a circle. We're looking at it in a representation of 3 dimensions, so it looks a bit squashed. But if that base is a perfect circle. Now we're told the curved surface area of a cone is given by this formula: pi times the radius times the slant height, which is called L. Pi times r times L. That's the radius. That's the slant height. That, remember, we said was the perpendicular height. And Beth's trying to work out the curved surface area in terms of pi. So here's her working. She's got pi times 5 times 12. She's used pi times 5 times 12. And she gets 60 pi. 5 times 12 is 60. So she's got the right answer from using these numbers. What mistake has she made? Well, has she got the radius right? Yes, she has. Has she got the slant height right? No, she hasn't. The slant height is 13, not 12. She's taken the perpendicular height instead of the slant height. So we'd have to say that she used the perpendicular height, and that's 12, instead of the slant height. Of 13. So she did make a mistake. Let's have a look at part B. Adam uses pi equals 3 to estimate the area of the base of the cone. And we have to work out his estimate. Now, remember I said the base of this cone is a circle. And the formula for the area of a circle is given by pi r squared. That just means pi times r times r. That is the area of a circle formula. So his estimate is 3, that's what he's using for pi, approximately 3, times the radius was 5, times another 5. Now there are all sorts of ways of doing that. 5 5s are 25. 3 lots of 25 is 75. Another way of doing it, 3 5s are 15. 15 times 5, you could do the remultiplications if you need. 5 5s 25, 2 to carry, 5 1s are 5, plus 2, 7. So 75, whether it's 3 lots of 25 or 15 lots of 5. So the answer, 75 square centimetres. Now there is a part C in this question. Beth's recovered from her mistake. She's now using 3.14 to estimate the area of the base. And we're asked, is her estimate going to be more or less than that estimate that Adam has used? Well, let's look at what's going on. She uses 3.14 times 5 times 5. So she's multiplying these three numbers together. Adam was multiplying these three numbers together. Now you'll notice she's using a larger estimate for pi than Adam was. Beth's estimate for pi, that's 3.14, is larger than Adam's. So therefore Beth's estimate will be larger than Adam's estimate. So we're going to have more than box is going to be ticked for that one. There we go. So here's question 23. Eric drinks 1/4 pint of milk in the morning and 1/2 pint of milk in the afternoon. And he does this for 30 days. And we're asked how many pints of milk he drinks in total over these 30 days. Now, there are several ways of doing this. Let's have a look at method 1. We'll consider one day where he's drinking 1/4 pint in the morning, and then in the afternoon he's drinking 1/2 pint. Now, what's 1/4 plus 1/2? Well, that's 1/4 plus a couple of quarters. That's 3/4. 1/4 plus 1/2 is 3/4. So one day, 3/4. So the total amount of milk that is drunk in 30 days would be 3/4 times 30. So how do you work this out? Well, you multiply 3 times 30. That'll give us 90. 3/30s are 90. And then divide it by 4. So we've got a division. We have to divide 90 by 4. So 4 into 9, 2 4s are 8, with 1 left over. And then we've got 4 into 10, and that goes twice. 2 4s are 8. And the remainder after all that is 2. So the total is 22 pints, and we're dividing by 4, and we've 2 left over. That's 2/4 left over, which is the same as 1/2. Cancel by 2 top and bottom. So it's 22.5 pints. Now, there is another method, and that's just to take the morning consumption, that's 1/4, and find out in the 30 days how much milk is consumed in the mornings. And there's a division, 1/4 of 30. So 4 7s are 28. 2 left for that. 8 from 10 is 2. So that's 7 pints, and again 2/4 left over, 7 and 1/2. But we haven't considered the milk he drinks in the afternoon. So each afternoon, 1/2 pint. And that happens over 30 days. So what's 1/2 of 30? 15. So the total in this case would be 15 plus 7.5. Now if we take 15 and add 7, 5 plus 7 is 12. 1 and 1 is 2. That gives us 22, and we've still to add that 1/2 on. So we get the same as before, 22.5 pints. Well, here's question 24, and we're given this equation to solve. 7x minus 22 equals 4x plus 29. Now, it's worth remembering what we're trying to do here. When you solve equations like this, you're trying to get all the x's, that's the letters, on the left of the equation, and try and move all the numbers if you like, to the right of the equation. And how do we do that? Well, equations are like a balance, and we must always keep the equation balanced. So whatever we do to the left-hand side of the equation, we have to do identically the same thing to the right-hand side of the equation. And if we're trying to get letters on the left and numbers on the right, then what's wrong? Well, this 4x, that's 4 lots of x, that involves a letter x, that shouldn't be on the right hand side. And it's an adding 4x, it's a positive 4x. So what's the opposite? How do we destroy an adding 4x? We would take it away. So the action we're going to take is to take that 4x away from the right hand side. What must we do on the left hand side? Exactly the same. So we'll take away 4x from the left hand side, and it'll still be balanced. We'll still be able to put an equal sign in the middle. So let's do that. If we have 7 x's and we take away 4 x's, what will we be left with? Well, we'll still have 3 x's left. 7 of them, 1, 2, 3, 4, 5, 6, 7. There's 7 of them, and we have to take away 4 of them. 1, 2, 3, 4. There's the 3 x's. That's what this means. 3 x's are left. We haven't touched this subtract 22. Now, there's 4 x's. We take them all away, we've no x's left, but we haven't touched that 29. So we've still got 29 there. So it's looking slightly better. Remember, letters have to go on the left. Well, there's 3 lots of x, so they're on the left. There's no more letters anywhere else. Numbers on the right, that take away 22 is in the wrong place. So let's get rid of this negative 22, or take away 22. What's the opposite of taking away 22? Well, it's adding 22. So here, the action we take on the left-hand side is to add 22 to get rid of that. Same action on the right-hand side. Otherwise, we wouldn't be able to say these two sides are equal. So let's do that. Have we touched the 3 lots of x? No, it's still sitting there. Taking away 22, adding 22, these two would cancel each other out. After all, if you give someone 22 pence and then you take the 22 pence away, you've got nothing left. So that just is a 0, empty. We don't need to write anything down for that. And what about the right hand side? 29 plus 22. Let's follow that one through. Got 9 plus 2 is 11. 1 and 2's 3 and 2's 5. So we get 51 for that. Okay, what's next? Well, we want to find out what 1x is. And at present, we've got 3 x's. And we know that's 51. So really we'd have to divide this 51 up into 3 bundles to find out what each of these x makes up. So that gives us the clue as to what we do. So we divide by 3. There's the x's. We divide by 3 and we just get one of them. And we do exactly the same to the 51. We have to divide this 51 up into 3 portions. Distribute them equally among the x's. So what is 51 divided by 3? Well, 3 into 5 goes once, with 2 left over. And 3 into 21, 3 sevens are 21. So we'll get 17. This 51 is being divided up into 3 bundles of 17. And that's what each x will be equal to. So on the left hand side we'll get 1x, and 3 into that 51 we know now goes 17. So our solution is x equals 17. Well, here we have question 25, and we're told that in a house the floor area of the living room is 26 square meters. So there's a living room which has an area of 26 square meters, and then there's a kitchen, and its floor area is a bit smaller than the living room. It's 16.4. So 16.4 square meters. Now, what's the question asking us? We have to express the area of the living room as a fraction of the area of the kitchen. Now, suppose this one, the kitchen, was a half the size of the living room. That half that I've mentioned is expressing the kitchen as a fraction of the living room. That would be 1/2. We're wanting it the other way round, and in that case it would be twice. The living room would be twice the size of the kitchen. If the kitchen's a half of the living room is twice the size of the kitchen. The larger number is on top in this case because this is larger than that. The living room's larger than the kitchen. So we're asked to express the living room as a fraction of the kitchen. We're going to have to put the larger number on top. So we can get rid of these. These are not correct. So let's just wipe these out. So what we're having to do is we're having to put the living room size on top of the kitchen size. So that's the fraction we're looking at. 26 over 16.4. And this has to be bigger than 1 because that living room is bigger than the kitchen. So how on earth do we work out this? We have to write it as a decent fraction without decimal points and so on. So how do we get rid of this 0.4? Well, why don't I multiply the bottom of this fraction by 10? Now, why am I doing that? Because the tens will become hundreds, the units will become tens, and these tenths here will become units. So in effect the decimal point is moved one place to the right. We've got the number 164. We've got rid of that annoying decimal point. But we've had to multiply the bottom of this fraction by 10. If you take a fraction like a half, for instance, and multiply the bottom of the fraction by 10, you would have to do that to the top of the fraction. 10/20, this is exactly the same as a half. So if we multiply the bottom by 10, we must balance it by multiplying the top by 10. So 26 times 10, that would be 260. And at least now we've got healthy whole numbers to deal with. So what's next? Well, you notice they're both even. Let's divide both top and bottom by 2. So 2 into 260, if you work that out, you'll get 130. Half of the 200 is 100, half of the 60 is 30. So that wasn't too bad. And what about 164? Well, a half of 16 would be 8, and a half of this 4 would be 2. So we'll get 82. Now look, they're both even. This could go on for a while. So let's half each of these again. So we're dividing 130 by 2. Well, 2 into 13, 2 6s are 12. There's 1 left over. 2 into 10, that'll be 5. So a couple of 65s give us 130. Let's balance it by dividing 82 by 2. So half of that 8 would be 4, and half of that 2 would be 1. A couple of 41s give us 82. Now, we've reached the end. They're both odd and they can't divide by 3 or 4. 41 is actually a prime number. It can't divide by anything else other than 1 and 41. So there's the fraction of the kitchen that the living room is, 65/41. Now, we can do better than that because we know that 41/41 give us 1. We've got 65/41. How many are left after we've taken 41 of these away from the 65 of them? Well, 24. So that's 1 and 24/41. We've got 41/41 plus 24/41 gives us 65/41. And that's our 1 and 24/41. So that's the fraction that they asked us to find. You'd actually get full marks just for leaving it as 65/41. So here we have question 26, and we're given a number line and we're asked to show all the numbers that lie between -2 and 4. That's all the ones from here all the way up to here. Now, the important point here is that we don't want -2 and we don't want 4. These are strictly less than signs. They don't have an equals in there. So to show that we don't want -2, empty circle. To show that we don't want 4, empty circle. If we did want 4, we would fill that circle in. And between these two, let's bring in the ruler to make the thing neat. So we draw a straight line right between these two, and you make sure that that line is thick enough to be seen. There we go. Let me just fill that in a bit. So there we have, very obviously, all the numbers between -2 and 4 filled in. We don't fill in the -2, we don't fill in the 4 because we don't want them. They're strictly less than. If the signs were like this, if that was one of them, we would therefore be allowed to fill. If that was a less than or equal to, we would fill that in. If that one was a less than or equal one, we would fill this in, because we would be then allowed the numbers to be equal to 4 or the numbers to be equal to -2. So there's part A. Let's have a look at part B. And we're asked to solve this inequality. 5y plus 14 is greater or equal to 11. Now we treat it in the same way as we do an equation, where if this number is bigger than or equal to 11, let's get rid of this 14. So if I take away 14 from 5y plus 14, then I would have to take away 14 from this 11. Otherwise I couldn't then say what I'm left with is still greater than or equal to this. So I have to do the same action to both sides of this inequality. So let's do that. We haven't touched that 5y. If we take away 14 from 14, we get 0. So there's nothing left there. And that's greater than or equal to, what's 11 minus 14? Well, on the number line, if you're away along at 11, there's 0. If you take away 11, you'll be there. We'll have another 3 to take away, so we'd be left with negative 3. So 11 take away 14 will leave you at negative 3. So what's next? Well, solving an inequality like this, we're wanting 1y, we don't want 5 times y. So again, let's do the same to both sides. What's the opposite of multiplying by 5? Well, that's dividing by 5. So if we divide 5y by 5, we'll get 1y. If I do that to the left-hand side, I must do the same to the right-hand side. So let's do that now. So we have 5 lots of y, and we find a fifth of that, we'll only have 1 lot of y. Divide that by 5, you'll get 1 lot of y. And that'll still be greater than or equal to, and what do we get when we take negative 3 and divide it by 5? Well, we get negative 3/5. There's one negative sitting there. Negative divided by positive is negative. We get the number negative 3/5 when we divide negative 3 by 5. And that's us solved that inequality. Well, here we have question 27. And we're given a diagram with a couple of shapes, and we have to describe fully the single transformation that maps shape A, that's the larger shape, onto the smaller shape. So the word they're looking for here is enlargement. And for an enlargement, you need two things. You need to know a scale factor. That measures how much bigger or how much smaller the new figure is, the new shape is, compared to the old one. And also, we need a centre. Now let's tackle the scale factor first. So we're going from this large shape, A, to a smaller shape, B. Let's look at the lengths of the lines on the sides. This bottom edge of shape A is 4 units long, 4 squares. Let's look at the corresponding bottom edge of shape B. It's only 2 squares long. So we've gone from 4 to 2. That's a half. We've taken this side and halved it to get this side. So we'd say that the scale factor is 1/2. The small shape is a half of the larger shape when it comes to the lengths of all the sides, and that's how you'd work out the scale factor. Now the centre. Let's have a look and see if we can find the centre. And the way we do this is to look at a point on the larger shape and look for the corresponding point on the smaller shape and then join them up. So you would take your ruler and line your ruler up so that it passes through both of these points. There it is. And we draw that line in. Now we do the same again for another pair of points. So this corner of the shape A corresponds to this corner of shape B. So again, we'll take the ruler and see if we can fit it exactly to these. You've got to be very careful with your setting up here. Now I'm getting that. That's pretty good. Let's join them up. And you'll notice what's happened, that these two lines have met down at this point. Let's take another pair of points just to confirm that. This corner or vertex of shape A corresponds to this vertex of shape B. Now that's an easier one to see where the line in this case goes, because it's a vertical line. It passes through these 2 points parallel to the y-axis. So all points and their corresponding point in the smaller shape seem to pass through this point. And this is the point negative, or 1, negative 7. And that's called the centre of this enlargement. Now, even though it's been reduced in size, we still call it an enlargement, because the scale factor of a half will then tell you that the size of the shape is going to be reduced. If the enlargement scale factor was greater than 1, say 2 for instance, then the corresponding shape would be twice the size. And it really would look like what you think of as an enlargement. So the scale factor is 1/2, and the centre of that enlargement is 1, negative 7. So in your working you would say that it's an enlargement, that its scale factor is 1/2, that the centre is 1, negative 7, and that would give you your 3 marks. Now here's a little demonstration of how things change in a diagram like this when we change the scale factor. At present, this is the picture you had in the question. Your scale factor is 1/2. Let's increase that scale factor. And you can see what happens. When the scale factor is 1, the shape is unchanged. When the scale factor goes larger than 1, for instance, suppose we end up at 2 for the scale factor, then you'll notice that this lower edge, which had a length 4, has now got a length of 8. That's twice the size that we started with. So that's a demonstration of how this transformation, this enlargement, affects the shape B from the shape A. And there it just disappears. When the scale factor is 0, it's vanished into the centre. So there's the picture as it was given to us. The other thing we can do is to see how, when we move the centre around, what happens to this reduced image. Well, there you go. You can see that it's always, if you like, halfway between the point and the centre. The corresponding point in the small shape is always halfway between the centre and the other point. So let's put it back where it started. And now here's the picture with the lines that we drew in, that all met at the centre. And if we move that centre around now, you can see how these lines from a point in the larger shape to the corresponding shape in the smaller shape always meet at the centre. And that's also true if we increase the scale of that enlargement. So I hope that's given you a better feeling for how an enlargement works. So that's Mr. Corsi signing out, and I hope you enjoyed the video.